All right, we are almost done. We have this real world application. So first thing I'm going to say is there's a couple typos. I want to apologize. This should say stage. All right, so the seats closest to a concert cost $30. And we're going to say that those seats that cost $30, we're going to say that those are in section A. All right, just to eliminate some confusion. The seats in the next section cost $25. We're going to say that those $25 tickets are in section B. So go ahead, before you even get started in this problem, if it's copied wrong for you, that's what it should say, right? And then lawn seats are $20. So we have three different seats, section A, section B, and lawn seats. There are twice as many seats in section B as there are in section A. When all 19,200 seats are sold, the concert venue makes $456,000. Determine how many seats are in each section of the concert venue. All right, so with a big problem like this, we need to follow some problem-solving steps. Okay, so step one, let's read the problem several times. If necessary, what is given, what is to be found. So we know that there are costs of tickets, and then we also know that when every single one of those is sold, the concert venue makes $456,000. Right? We also know that there are 19,200 seats total. And then we also know that there are twice as many seats in section B as there are in section A. All right. Step two, we want to assign some variables to represent the unknown values. If you're not sure what your variables are supposed to be, just go to the last part of the question and see what the task is, and then you can use that to help you. Right? It says determine how many seats are in each section. So we should probably make our variables be seats in each section, right? So number of seats in section A, Y should be number of seats in section B, and then Z, we can have Z be, that's a really sad number symbol, sorry about that, number of seats in the lawn, all right, lawn seats. Okay. And then step three, we want to write a system of equations. So make sure you define your variables very clearly for me. I am not inside your brain. I might not know what you are thinking if you do not label your variables. All right, we're going to write our system now. So I kind of color-coded this for you. We're going to write a system relating the prices. All right, so if I buy a seat in section A, it's going to be $30. $30 times the number of seats I sell in section A will give me that price. So 30x plus 25y, same thing for the other sections, plus 20z. When all those are sold, it's going to be equal to, actually, you know what I'm going to do? I'm going to label these a little bit differently so that I'm following the work that I already have written down. I apologize for that. All right, what we're going to do first, we're going to say, all right, there are 19,200 seats total. So when I add x plus y plus z, all the numbers, it should equal 19,200, all right? And then we can go to the price thing. I was jumping ahead of myself. 30x plus 25y plus 20z. When we sell all of those, it's equal to $456,000. We also have this piece of information relating the seats in section B and section A. So we're just going to say that, all right, y equals 2x. All right, and these are going to be our A, B, and C equations. So let's see if I can save that. Well, no, that's not what I'm going to do. Here's what I'm going to do. Here's what we're going to do. We're going to take this, we're going to copy it, and let's go on to the next page. All right, so we're going to solve the system of equations. So what we're going to do is label them A, B, and C, just like we've been doing, A, B, and C. And then notice that y equals 2x. We already have some variables eliminated here, so we can just kind of use some substitution. All right, let's sub C into A, and then let's sub C into B. All right. So what's fun about these is we can kind of use different pieces of information that we know to move forward. Okay. So if we do sub C into A, we'll end up with, I'll write this up for you, x plus, change colors, x plus, instead of y, I'm going to write 2x. Plus z equals 19,200. And then subbing c into b means that 30x plus 25, instead of writing y, I'm going to write 2x plus 20z. I don't know why it does that. It changes my color. Plus 20z equals $456,000. All right, so now I have another system of equations that's in two variables. I'm going to clean them up a little bit so you can see what I'm saying. All right, so x plus 2x plus z, that gives me 3x plus z equals 19,200. 30x plus 25 times 2x is going to give me 80x plus 20z equals 456,000. And so I'm going to give these a label, equations D and equations E, and then we're going to use elimination to get rid of either the x or the z, and then we're going to keep on chugging along. Okay, so look at this system and see, all right, what can I do to try to eliminate either my x's or my z's? I see that I have a z by itself, so it's going to be kind of nice to multiply that. I can multiply it by negative 20. So I multiply d by negative 20, and I can add it to e. That's going to cancel out my z's, right? So that's going to end up, I'm going to write this out, negative 20 times d will give me negative 60x minus 20z equals, don't forget to distribute, you're still multiplying 19,200 by negative 20, even though it's going to be a really big number. It equals negative 384,000, and then we're adding it to e, which is 80x plus 20z equals 456,000. And we are adding those together, all right? So then we'll have 20x equals 72,000. Divide both sides by 20 to get that x equals 3,600. So, whew. A lot of steps, long journey, and we're not done yet. We just know our x. We don't yet know our y or our z. So we got to keep going. We're not done. All right? What is nice, though, since I know this x, I can go back to my original set, and I can plug in x here and figure out what y is pretty quickly. All right? So I can see y equals 2 times 3,600. And I would get that y is equal to 7,200. So now I have a number for my y. Last thing I got to do is figure out my z. So to figure out my z, I know x, I know y, which means I'm going to have to go back up to one of the originals. Go back up to one of the originals and use an equation that has z in it. I'm going to use the top one because it's going to have the least amount of division required. All right, so we're almost there, I promise. You guys are troopers. Okay, so plugging this into the first one, we'll have 3,600 for x plus 7,200 for our y plus z equals 19,200, meaning that 10,800 plus z equals 19,200 and z equals 8,400. All right, so that is step 4. That is step 4. We have numbers for all our variables. Step 5, since this is a word problem, we have to label our answers using correct units. So our x was 3,600, meaning that there are 3,600 seats. And you're like, I don't even remember. I just did so much work problem solving. I can't remember. Well, good for you. You already labeled what units each variable has. All right, go back up to step 2. Look at that and see, oh, x would be number of seats in section A. And then for y was our seats in section B, so there are 7,200 seats in section B. And then for our z, there are 8,400 seats, and those are lawn seats, so that's what you could write. All right. Last thing we want to do, check and make sure that these answers make sense. So you want to plug in x, y, and z to one of your originals. I'd recommend plugging it into maybe the middle one because we haven't used that one very much. All right, you could plug it into A or B though. But you want to make sure you're plugging it into an equation that uses all three variables. So let's say I choose the bottom one is 30 times 3600 plus 25 times 7200 plus 20 times 8400. Is that equal to 456,000? Plug and check and see that yes, that is true. So your answer makes sense. All right, that's a word problem. There's a lot to these systems problems. It just takes practice. All right, take a look at the homework. Let me know what questions you have.